Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, heat treatment, and how aluminium is rolled, extruded, and/or welded. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. In this module, we shall examine and explain the various methods of hardness testing. We shall understand how to carry out those tests. And perhaps most importantly, we shall appreciate that hardness testing can be used as a quality control tool. You will learn about the different methods of hardness testing. Specifically, we're going to look at two methods, the Rockwell hardness test and the Brunel hardness test. You will learn how to select the correct hardness test for your application, for your project, for your products, for your manufacturing lines. You will learn about the versatility of hardness testing and how it can be used to prove product quality. Through the correct selection and application of hardness tests, you will be able to establish product quality. You will be able to design hardness testing into production and manufacturing situations to ensure product quality. In simplistic terms, all hardness tests involve pressing a dimensionally very accurate indenter, a very hard indenter, either a hardened and tempered steel ball, or in some cases a diamond, under a known load into the surface of a metal or a component, and then measuring the resultant plastic deformation. Fundamentally, to indent the metal, a hardness test has to yield the metal. It has to plastically deform the metal. So the indentation is a measure of resistance to plastic deformation. And so a hardness test can be used to estimate tensile strength. In the previous module, we saw how tensile tests are carried out. Tensile tests involve a tensile testing machine, quite a complex, very expensive piece of equipment. They require quite a high level of skill to carry out, and the results require quite in-depth engineering knowledge to interpret. Most importantly, a hardness test is a tensile test is a destructive test. So a tensile test is a destructive test. You take a sample of what you're producing and you test it and you destroy it. So a tensile test cannot be used as a quality control tool. It is a sampling quality proving tool, but cannot be used as part of a production line. Now, hardness tests leave a very small impression, a small indentation. So they are non-destructive methods of confirming mechanical properties. They can estimate tensile strength. We can use hardness tests to prove heat treatment. We can test a complete heat treated batch to ensure heat treatment. Because hardness tests are non-destructive, they can be used multiple times on the same component or the same product. So when we are establishing heat treatment, age hardening, as we shall discuss in future modules, we can age harden that same component over and over again and hardness test it till we've got the exact right results without destroying the component. Production lines and manufacturing processes, hardness tests can be used as product checking or as a sorting tool, or indeed as a quality proving tool. Now, most importantly, because the hardness test leaves an indentation, it is proof that that product has been hardness tested. The first test that we're going to look at is the Rockwell hardness test. Now, the Rockwell hardness tests measures or indicates hardness by using a dial gauge, a depth gauge, to measure the depth of the impression. For Rockwell hardness testing, the surface has to be parallel, flat, and is prepared by lightly grinding to approximately a 400 grit. For aluminium, we used the Rockwell B scale. And the Rockwell B scale is one of a series of scales that go from A through B, C, D onwards. And each scale is targeted at a specific range of hardness or a specific material. So we use B scale for aluminium. For hardened and tempered steel dies, we would use C scale. Now the B scale uses a 1/16 of an inch ball indenter. 1/16 of an inch is very approximately 1 millimeter. And we use an indentation force of 100 kilograms. So quite a low force. The way we carry out a Rockwell hardness test is to place the test piece on the platen, bring the platen up to the indenter, and then we apply a minor load to zero the depth gauge onto the surface of the aluminium. Then we apply the major load, remove the major load, and then the Rockwell tester measures the depth of the impression. And the depth of the impression is reported or indicated as a hardness Rockwell number, HRB. Because the hardness test, the Rockwell hardness test uses a 1/16 of an inch indenter and a low load, it's a semi-micro test. So it is perfect for measuring sheet rolled aluminium, for checking tools and dies.